Hello and welcome to SudoKanard. We're here to solve this liar odd even Sudoku by Tyler Chen in Sudoku Grand Prix. That was the USA round. This was worth 63 points, which means that the difficulty is kind of middle of the road, or considering the round it was in the easier puzzles, I must say, except that it was not found that easy by many people, and I agree that it was not that easy. I was fortunate enough to find a way to solve it, to find a breaking, but it's, well, I may have been lucky in that regard. So the rule here is the usual rule of odd even Sudoku is that those squares contain even digits and that those circles contain odd digits. But the twist is that exactly one of those given symbols is wrong. One of them, perhaps this contains an even digit, perhaps this contains an odd digit, but exactly one of the symbols is wrong. And it is part of the puzzle to find which symbol is wrong. And something, well, I will go straight to the point. When I tried to solve this puzzle, when I solved it during the contest, I found there must be a way to reduce the set of possible liars. To say the liar is necessarily among this set of symbols. And what I notice is that there are a lot of given odd digits. And actually I'm seeing that a 7 goes there just by a standard Sudoku. But there's an interaction between odd digits and the given squares. Such an interaction is here. You see the 3? So 3 is in one of those cells. And if you assume that those squares are correct, then 3 must go there. So I will use some color, let's say brown. Let's assume for a moment that those squares are correct. In this case, 3 will be in one of those. And likewise, if you assume that those squares are correct, then they must contain even digits, and this 5 here will go in one of those two cells. And there you have a 5, a 7, a 3, and a 9, which means that the only remaining odd digit in the column is the 1, which will have to go in one of those two cells, and the other circle will have to contain an even digit. So to sum it up, if I assume that all 4 squares are correct, then one of the circles here is wrong. So we are left with 2 possibilities. The first possibility is that all squares here are correct and one of the circles is wrong, or one of the squares is wrong, which means that the only possible wrong cells, wrong clues, are those 6 clues. And all other given clues are correct. So I will now use some coloring. I didn't use coloring when I solved the puzzle on paper, obviously, but it will help me in my exposition. So I will use orange, and I'm saying that, well, maybe yellow will be an easier hue for those. So I will use orange for odd digits because orange starts with O. Oops. So odd digits will be painted orange and even digits will be painted green. I think I did things correctly. And now Now let's have a look at what can be done. I can do some pencil marking. For example, those are 2 and 4. And saying this now has to be an odd digit. And it places 5 odd digits on this row so that the other digits are even. And now we have 4 even digits here, so those 2 are odd. And by the way, this must be odd. So now we have 5 odd digits in this column, so the remaining cells must be even. We have 4 even digits in this region, so those 2 cells must be odd. We have 4 even digits in this column, so the remaining cells must be odd. We have 5 odd digits in this column, so the remaining cells must be even. So this falls into place quite nicely. And I think that this is it for the time being. And I will have to do some Sudoku now. Oh, I'm saying 8 is not here, 2, 4, 6 are not here. This is odd. I will still need to find 8 on this column, but now is not the moment to do so, I think. So let's do some more Sudoku. This 4 in this column can only be here. Those are 2 and 6. There will be an 8 somewhere here. Those are 2, 6, 8. This is not 8, so that this is 4. This has to be 6. That's not 6, so this is 2 or 8. This, actually, this is the 6, so that this is 2, this is 6. Here we need 2 and 8. This is not 4 because of that, so this is odd. We have 5 odd digits on this row, so the remaining cells are even. And this here is now odd. Oh, and I should delete those pencil marks because they were there as illustration. Well, this is actually a 3, considering all of this. By the way, how am I knowing that this is odd? What did I do? All right. What did I do? I was saying those 2 are even. All right. So I was just messing up. So those 2 must be even. And this is it. Oh yes, I painted this one odd because I felt the 3 had to go there. But we don't know that yet. It may be the case, but we don't know that. What is the next step? I think I can pencil mark those 2. Those are 5 and 9. Oh, actually 9 is not here, so 9 goes there. This is 5. There will be a 1. Actually, this is 2 or 6, so this is 1 or 2. This is 1, 2 or 6. This is a 4. And this is odd. This is 2 or 6 or 8. Sudoku tells me that this is 4. Now, let's move on with Sudoku. This 5 tells me that this is 3. This is 5. This is 5 or 7. What am I doing? This is 5 or 7. This is 5 or 9. And this is 7 or 9. This is 1 or 7. This is 1 or 9. And this here is 1 or 7. So that 9 in the column is here. And this is 7. This is 1. This is 7. This is 5. This is 9. And now Sudoku tells me that 7 goes there. No. So what am I doing? No, Sudoku tells me that 7 goes there. That was a spectacular bug. This 3 here goes there, so this is correct and this is even. This is a 3. We'll still need to place 1 and 5 in the column, and we can see that none of them is here. So this is even. This is 2 or 6. By the way, that's a 3. This is 1 or 7, and actually 7 here goes there. Those are 1 and 9. And we still need to place a 3 somewhere on this row, and we can see that 3 goes there. So this is the layer. And we can now understand that this is even. This is also even. This is odd. This is now odd, and those are even. And we're left with a standard, how is it called? Standard odd-even Sudoku. With this 3 being the layer. So that's not a 1. That's the 1. This is 8. This is 4 actually. 8 is somewhere. No, not that. I need a 5 somewhere, and 5 is here. This is 2 or 8. It would be so easy to mess up. It would be so canard. Here I need 1 and 9. There's a 9 here, so 1 here, 9 there. This can't be a 5, so that's a 3. Here I need 5 and 8. Those are from 2, 6, and 8. This is from 2 and 6. This column still needs 1, 9, and 8. So this is 8, 5, 8. And that has to be a 2. This column needs 1, 9, and 3, so 3 goes there. This is 1 or 9. This is 1, this is 9. This row needs a 5. This column needs a 1. Here I need a 1 and 8. So now it cracks the puzzle open. I don't think I need to comment on those placements. And this is finally a 4, and this is 8. So really, the initial logic to limit the possible placements, to restrict the set of possible layers was really a key step. I don't remember how long it took me to notice that, but I remember that right from the get-go, this 3 and this 5 looked suspicious. So that was a very nice logic, but not necessarily easy to see, and it was not necessarily easy to think of that. Perhaps there was another method, and if you found another method, feel free to mention it in the comments. For the time being, thanks for watching this video, and see you soon on SudoKanard.